Right, ready, set, go on Systems 2.4. So make sure that you guys are trying all of these problems beforehand, and you're using this to help you see what you did right or what you did wrong and how to learn from those mistakes. So, the first problems. Determine whether h equals 3 is a solution to each problem. Well, how do we check if a number is a solution? You take your equation, and wherever that variable is, we replace it with 3. We substitute 3 in there, and then we simplify to see if they match up. So 3 minus 4 is negative 1. Use an order of operations. We do inside the parentheses first. 3 times negative 1 is negative 3. Does negative 3 equal negative 3? Yeah. So yes, that is a solution. Okay, then we try 2. Same idea. We've got 2 variables this time. So we plug in 3 to both variables. Remember, 3h is 3 times h. So 3 times 3 is 9. 3 plus 2 is 5. Times 2 is 10. These are not equal. So that is not a solution. Okay, same idea here. 2 times 3 minus 3 equals 3 plus 6. Let's see if it works. 2 times 3 is 6. 6 minus 3 equals 3 plus 6. You should be able to tell right now this is not going to work. Okay, now we got an inequality, but we treat it the same way. Put the 3 in there. 3 times 3 is 9. Is 9 greater than negative 3? Yes, it is. So this would be a solution. And the last one, even though we got fractions, we still treat it the same way. So 3 in for h. Then we make that a fraction. When we multiply fractions, multiply tops, multiply bottoms. Does 3/5 equal 3/5? Yes. So there we go with those guys. Alright, now let's take a look at these ones that this is what we were practicing in class. So graphing system of equations. So remember, the whole point, the steps are, okay, if you've got a story problem, first step would be to make your equations. Okay, then you graph both equations on the same coordinate plane. That means on the same graph. You're graphing them together. Then we're looking for where they intersect. Okay, that point where they intersect is your answer. Okay, so let's take a look at this first one. So the difference of two numbers is 3. Their sum is 19. So there's 2 things here. Okay, now, do we know what those numbers are? No. So we use a variable in place of them. Now I said the difference of 2 numbers is 3. So if I take x, subtract y from it, that should equal 3. Their sum is 19, so x plus y should equal 19. So there's my 2 equations. Now, we could graph them in this format, standard form, but it seems like a lot of you prefer to turn it into slope-intercept form. So let's do that. So for this one, I'd subtract x from 19. Now, we don't know what that is, so we go just negative x plus 19. We can't combine that, remember. So there's my first one. So I go up to 19, which I believe is right here. And then my slope is a negative x. Remember that negative x is really like a negative 1x. So my slope is really like negative 1 over 1. So I'm going down 1 and to the right 1. So here is my first line. And remember, when you're graphing equations, you want to put all the possible dots on here. Okay, because we don't always draw a straight line. So it's easier to know exactly where your dots are, so you know exactly where to hit them. Okay, now let's take a look at this equation. So we'd subtract x from both sides here as well, and you get negative y equals negative x plus 3, because we've got to keep that negative with the y. But we don't want that negative with the y, So if we times everything by -1, we get positive y equals positive x minus 3. Which means I'm going to have to extend my graph down here. So my y-intercept is -3. My slope, x is like 1x, so 1 over 1. So up 1 to the right 1, up 1 to the right 1, up 1 to the right 1. Okay. We should see very easily where they intersect. So we know that point's our answer. Well, what is that point? So y value of 1, 2, 3, 4, 5, 6, 7, 8. X value of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11. So that point there, 11, 8. So our answer is 11, 8. One number is 11, one number is 8. They add up to be 19. They subtract to give us 3. Alright. So let's take a look at another one. Shauna and Elisa each improved their yards by planting hostas and geraniums. They bought their supplies from the same store. Shauna spent $168 on 4 hostas and 14 geraniums. Elisa spent $77 on 1 hosta and 7 geraniums. Find the cost of 1 hosta and the cost of 1 geranium. So, once again, we don't know the cost, right? So, we know what our variables are. We'll say x is the cost of the hosta. And y we'll say is the cost of a geranium. Okay? Now, think about it. How are we going to make an equation? Well, how would I figure out, if I knew how much the hostas cost, and I bought 4 of them, how would I figure my total? You'd go 4 times whatever number. So I'm going to go 4 times x. Then for the geraniums, you'd go 14 times its cost, y. You'd add those two together, and that equals how much you spent, which we know was 168. Okay, so now we can solve for y to graph this. So subtract 4x from both sides. We get 14y equals negative 4x plus 168. Then we divide everything by 14. To get y equals, let's see, negative 4 over 14 would be what? Negative 2/7 x. And leave it as a fraction because we know it's our slope. Then 168 divided by 14. What is that going to be? Let's see, it would be 84 over 7. I believe 7 can go into 84 12 times, right? Yeah. Because that would be 84. That's what I thought. Good. So that makes a nice number. 12. So we got our first graph. So we go up to 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, my slope is down 2 to the right 7. So down 2 to the right, 1, 2, 3, 4, 5, 6, 7. Down 2 to the right, 1, 2, 3, 4, 5, 6, 7. Down 2, 1, 2, 1, 2, 3, 4, 5, 6, a little off the graph. So there's our first graph. Now we do our second. So we had 1 hosta, so 1x, 7 geraniums plus 7y is equal to 77. So subtract the x, we get 7y equals negative x plus 77. Divide everything by 7. We get y equals negative 1/7 x plus 77 divided by 7 is 11. So go up to 11 for our y-intercept. Down 1 to the right 7. Down 1 to the right 7. Down 1 to the right 7. You can see our line. And they intersect right there. Which is what point? 1, 2, 3, 4, 5, 6, 7. 7 for x. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 for y. So what does that mean? It means the cost of the host is $7. And the cost of the geranium is $10. And there we go. Okay, we've got another one, so it's kind of the same process here. Okay, Rob selling tickets to the fall musical. First day they sold 12 adult, 11 child, for a total of 180. Then the next day 140 by selling 2 adults and 11 child. Find the price of an adult ticket and the price of a child ticket. So we'll say X, or yeah, we'll use X. X we'll say is adult ticket price, and Y is child price. Then we make our first equation, 12 adults, so 12 times X, plus 11 child, 11 times Y, equals 180. Okay, our second equation, we've got 2 adults, plus 11 children again, and that one equals 140. So then we can turn these into slope-intercept form if we want to. We could try to graph them like this if we wanted to, but it seems like we do better graphing them the other way. So we get 11y equals negative 12x plus 180. Divide by 11. Get y equals negative 12 11ths x plus 180 over 11. Ugh. That's a really hideous looking one, isn't it? Because I don't think 11 goes into 18 very well. What about our other one? Subtract the 2x. We get 11y equals negative 2x plus 140. Divide by 11 again. Ugh. Y equals negative 2 11ths x plus 140 over, whoops, hit my 140, let's scoot that down just slightly, 140 over 11. Okay, so what do we do in cases like this? Well, the easiest thing to do is to rely on some technology to help us graph these, okay? Because these are definitely not pretty looking equations, right? Now, a really great one you can use, it's called Desmos.com. It's a really easy to use graphing calculator, and in situations like this, you know, that can help you out immensely. So let's take a look and see what we get here. The reason I really like Desmos.com is because I can actually type in these equations and I can use it to check my answer, okay? Or to, in this case, I don't want to deal with these guys, so I can use it to graph these and go from there. By the way, you can also get a Desmos app, I believe on both Android and iOS devices. I know my iPad has it, so I'm pretty sure the iPhones can get it. I'm pretty sure they have an Android app. Just look for Desmos. Though, just to let you know, on a lot of these problems, they're easy enough to graph by hand that always using this Desmos isn't great. It's more to use to check your work and to, when you've got these difficult equations. That's why they make the technology, so we might as well use it, right? So, I just copied and pasted the graph here. So, notice our y-intercepts were decimals, right? Because 180 over 11, 140 over 11 don't come out to be nice, neat numbers, which makes it tough when we're graphing. Okay, notice our x-intercept here was 15 for the blue graph. It went clear out there. But here we can see exactly where they intersect. 412. Okay, that point, 412. So what does that tell us? It tells us an adult ticket is only $4, a child ticket is $12. Which would be an interesting thing to do it that much. Alright. So see how that technology can help us, because all we're doing is just trying to graph equations and go from there. Okay, but it does take longer in some situations. Sometimes it's a lot easier, like when we get to these guys, much easier to just do it by hand because we can do it so quick. Alright, so let's see what we got here. So, senior classes at High School A and High School B plan separate trips to the state fair. The senior class at High School A rented and filled 3 vans and 3 buses with 198 students. High School B filled 9 vans, 4 buses with 334 students. Every van had the same number of students in it as did the buses. Find the number of students in each van and in each bus. So we want to know how many people were in the van and how many people were in the bus. So take the number of vans, times them by how many people we can have in a van, add to that the number of buses, times how many people we can have in a bus, and we know that has to equal 198. Okay, so subtract 3x, we get 3y equals negative 3x plus 198, divide by 3, and we get y equals negative 1x plus 198 divided by 3 is what, 66? 18, 19, yeah. Okay, see now that one's fairly easy to graph, even though going clear up to 66 is going to be troublesome with our graph. But let's try the next one. So 9 vans and 4 buses equal 334. Okay, so subtract 9x from both sides. We get 4y equals negative 9x plus 334. Divide by 4. We get y equals negative 9/4 x plus, can 4 go into 334? Goes into 33 8 times, that's 32 minus 14. No, it won't go in evenly, will it? So we could cut it in half. Divide 334 by 2. Would go into that. Once 2 minus 1, 3, 6, 12 minus 1, 4, 167 over 2. See, once again, here's another one where it'd probably be a good idea to use that Desmos, even though we could probably figure this one out. Okay, sometimes you have other graphs, and we will start learning that there's some other ways to do this, because sometimes graphing has it's not always the easiest or the best. So once again, using Desmos, we can graph that. We see that y-intercept right here would be 83.5. Okay, whereas our other y-intercept here was 66. Okay, and then as we're going down, where do they meet? They meet at 1452. So in the vans, right, that was our x. They fit 14 people. In the buses, they fit 52. Alrighty. Okay, now with these ones, we don't have to deal with creating the equations. All we got to do is graph them. So they're in slope-intercept form, so our y-intercept is negative 3. Our slope is negative 7 over 2, so down 7 to the right 2, or up 7 and to the left 2, which that's the one I'm going to do. 1, 2, 3, 4, 5, 6, 7, 1, 2. Okay, there's our first line. Second, start at positive 3. A slope of negative 1 over 2, so down 1 to the right 2. Or we can also go up 1 to the left 2, which you should be able to see exactly where they're crossing now, which is right here. What's that point? X value negative 2, Y value 4. There's our answer. Now, if we had a story problem, that would stand for something. We don't have a story problem, so that's all we got. Now, moving right along, positive 3. See, so actually going back to this one, you could type that into Desmos and find it out as well, but see how much quicker it was? It's actually a lot quicker just doing these ones by hand. So, number 11, positive 3 for our y-intercept, 2 over 3 for our slope, so up 2 to the right 3 because they're both positive, or we can go down 2 and to the left 3. There's our line right there. Okay, second one, y-intercept a negative 1. Slope of 2/3 again, so up 2 to the right 3, or down 2 to the left 3. And we should notice what happens when we have the same slope. When they're the same slope with different y-intercepts, they're parallel lines. Okay, do parallel lines ever intersect? Nope. So will these lines ever intersect? Nope. So our answer is no solution. They're never going to intersect, so there's never an answer. Okay, let's just keep trucking. Remember, you guys should try these on your own first, then use it to check your work. Okay, great way to check that work. So negative 2, y-intercept, going up 3, to the right 2, up 3, to the right 2, or down 3 to the left 2. There's our first one. Second one, positive 3. Negative x, remember that negative x has a slope of negative 1 over 1. So down 1 to the right 1, down 1 to the right 1, down 1 to the right 1. Or up 1 and to the left. Okay, pretty easy to see where that one goes. Right there, x value of 2, y value of 1. There's our answer. You should be writing your answers in that point form, met. Okay, now, if we look at 13, we should notice that it's not in slope-intercept form, but we can easily change that. So we get y equals negative 2x minus 2. So start at negative 2. Make a slope negative 2 over 1, down 2 to the right 1, or up 2 to the left 1. Same pattern. Okay, there's our first line. Second one, subtract 2x from both sides. We get 3y equals negative 2x plus 6. Divide by 3. So you should see that this pattern of solving for y, we pretty much always start by adding or subtracting the x value, then dividing by the coefficient of the y, and that usually gives us it. So positive 2, down 2 to the right 3, or up 2 to the left 3. You can see where it intersects at negative 3, positive 4. There's our answer. That's the point that works for both the x and the y, and will get us an answer that's a solution. Okay. Now 4 equals y. Remember, just go up on the y-axis at 4, and so we draw a horizontal line. Then to get that one, we're just going to divide everything by 2. So we'd end up with y equals negative 5 halves x minus 1, because 2 over 2 is 1. So down to negative 1, down 5 over 2, or up 5 over 2. Pretty easy to see where that one hits. Right there at negative 2, positive 4. There's our answer. Alright, so we can see all we're doing is just trucking along with these. Okay, 17. Positive 1 for our y-intercept, negative x, so it's negative 1 over 1. So down 1 to the right 1, or up and to the left 1. You can see our line there. Negative 2, so down 2. Negative 1 over 4, so we're either going down 1 and to the right 4, which that's all we need to do, or up 1 and to the left. Okay, where does it intersect? Right there at y value 4, x value negative 3. Okay, positive 3. 2 for a slope, so make that 2 over 1. So up 2 to the right 1, or down 2 to the left. Same pattern. Negative 2 to start us. 1 over 3, so up 1 to the right 3, or down 1 to the left 3. Should be able to see where it intersects right there at negative 3, negative 3. There's our answer. Okay, now if we look at number 15, these ones are a little crazier, aren't they? So we just keep going the same way. Okay, I could add the 8 to get it over with the 3x. So we'd have 2y equals 3x plus 8. Divide by 2. Get y equals 3 halves x plus 4. So graph it up 4. We're going up and to the right or down and to the left. So down 3 to the left 2. There's our first line. Now we graph the next one. That one right there. So we'd subtract a 3x from both sides. So we get negative 2y equals negative 3x minus 8. Divide by negative 2. And we get, that would cancel, y equals negative over negative makes it a positive 3 halves x. Negative 8 divided by negative 2 is a positive 4. And what do we notice? Same exact line. So this line overlaps, right? So what does that mean? It means it's always intersecting, right? So how many answers do we have? There's infinite solutions. Every single, because they're the same line, every single one of these points is an answer. So we say infinite solutions. All right, now these last two, just kind of reviewing with the inequalities. We've got our line already. We've just got to decide what part are we shading. Up or down, to the right or to the left. So we pick a test point. Remember our favorite test point, 0, 0. So into the y value we put a 0. Into the x value we put a 0. And then we simplify. 1/5 times 0 is 0. 0 minus 4 is negative 4. Is 0 less than or equal to negative 4? No. So that's not a solution, which means we shade the opposite side. Okay, same idea here. Pick our point 0, 0. 0 for y. 0 for x. Negative 3 times 0 is 0. 0 plus 5 is 5. Is 0 greater than 5? No, so that's not a solution, which means the opposite side is where all our solutions are. Okay, same idea with these ones. Oh, that was a horrible tracing. A little better. Pick that test point 0, 0. 0 in for x, 0 in for y. And then simplify. 5 times 0 is 0. 2 times 0 is 0. 0 minus 0 is 0. Is 0 less than 10? Yes, which means it is a solution, so I shade that side. Okay, and finally our last problem. Pick my test point 0, 0 one more time. 0 for x. 0 for y. Is it greater than or equal to 24? 0 plus 0 is still 0. 0 is not greater than 24, so we shade the opposite side. Alright guys, there we go.